So what a data model is a generally agreed upon standard for representing information about a given object. This can be almost any object, and so we've chosen a very simple example here. And actually, this particular example comes from a tutorial that was written by a team in Manchester, the University of Manchester. So examples of a simple data model for something like a pizza would be that a pizza has a base, a pizza has a topping, a pizza has a spiciness level, right? And a type of pizza may have a country of origin. How you might use that very simple data model of a pizza is to say, my pizza, right? So now I have an actual specific pizza, which I'm calling my pizza, and I'm saying my specific pizza has a base called cheesy base, right? Which is another specific object. So my pizza has this sort of, property called cheesy base, right? I can do the same thing. My pizza has a topping, so this is a specific type of topping, and the specific type of topping that it has is a pepperoni topping, right? And I can use this to express things about the object in information format without having access to the actual object itself. I'm describing the object using a general model of what the object is supposed to look like. So taking that simple example and then sort of making it much more complicated, what has been going on for the last few years and even before people have been coming up with data models to represent incident or threat information and then use those data models in popular protocols for sharing information with each other. So there's been a variety of different teams that have created a data model for threat information as well as for incident information. And some of the examples of those popular sharing models include STIX and TAXII, which is the structured threat information expression, and the trusted automated exchange of indicator information. There's a format called IODEF, which is the incident object description exchange format. A separate one is OpenIOC, Open Indicators of Compromise. And then there are other systems such as SES-SIF, which is a security event system and collective intelligence framework. Facebook has a threat exchange which implements their own idea of a data model. CRITS is another tool, collaborative research into threats, and they have their own specific data model. So this is just an example of how you may express a data model. This is the data model for IODEF. It defines a data format for communication, and the incident description is comprised of classes and subclasses. In this case, IODEF is defining the time of detection, the time that the incident started, the time that it ended, the time that it was reported, an assessment of what happened, the method of the attack, a description of the attack, and then also additional data about the event, such as enumerations of various different objects that could have happened during this incident. The origin of OpenIOC, it was originally designed to enable some products from Mandiant, and then in response to the user community, Mandiant ended up standardizing it and open sourcing the format so that others could use it and also use the schema for themselves. So you can see here that this particular example is describing an instance of the Zeus malware. The author is Mandiant, and it's telling you in machine-readable format that there's an indicator called winlogon.exe, and that particular indicator is a file name. So in addition, here's an example of another data model, which is from SES-CIF, now run by a team called CCERT Gadgets. And you can see here various parameters. This is just a snapshot. There's a much larger list at the link at the bottom, but you can, for a given indicator, you can say what ID it's from, you can say what confidence you have in it, you can give a very short description of it, you can put the restrictions on it. So this is actually applying the traffic light protocol at the very low level of each specific word that I tell you may have a different traffic light protocol associated with it. So you can tell other people these words, but not those words. And then a source from where you got it from. So you can really express a lot of information about even a very small value that you may have found using one of these structured formats. Here's an example that's taken from the Facebook Threat Exchange. You can see here, this particular example is you can query for a given indicator. In this case, that's the ID number. Facebook has an assignment of the ID number for any given indicator. And you can say this particular ID number has the following signatures. So the MD5 signature is this string. The SHA-1 signature is that string. The SHA-256 signature is this string here. I can give it a current status, and I can query and see how many victims have reported that they've encountered this particular indicator. So if I've encountered it, I can query the threat exchange and ask how many other people have encountered any of these values and find out the answer. Here's some additional fields that are tracked by the Facebook Threat Exchange. So things like the kind of attack that a given threat indicator object has been associated with, a description if it's a piece of malware, a description of the type of logic or the automation that's used to create that malware. These are all different properties about the actual object that you can specify using a data model.